Good afternoon, Mr. Goldberg. This is Freddie Martinez, and this is going to be my recording for the the first observation in the second session. Okay. Okay. So, good morning, class. Today we're going to be talking about gravity's role in the solar system and the galaxy. Okay. So, first thing we got to go over is the learning target and the success criteria. I'll have a student read out the learning target. Students will learn how solar systems and galaxies form, and and I have another student read out the success criteria. Students will identify centers of gravity in masses. Okay. So before we go on, I'll have the students review. So first thing I want you guys to review is draw or type two things you already know about gravity. This is something that we've talked about in a previous class, a previous lesson. So give me draw or type two things you already know. If we're doing this online, I would have the students directly draw on the slide. This is an interactive program called Pear Deck, in which they can draw or type their responses directly on their slide, and I could see their responses. If we're doing this in class, I would have everything done in their journals. Okay, I'd give them about 4 minutes to complete this, and I would call on two students to give me no, I think I'd call on four students. Call on four students to give me their responses. One thing that they know about gravity. Okay. Okay. So after that, we'll go into the review. So well, what do you know about gravity? Okay. So gravity is a force that attracts two bodies towards each other, right? So an example of that is the objects on Earth's surface are pulled toward the center of it by gravity. Okay, we know this because we've experimented with tennis balls, basketballs. We know that in any direction that you throw something, it always comes down and hits the Earth's surface. Okay, the gravitational pull depends on the mass of the object. Larger objects have greater gravitational pull. Okay, our example of this is both, excuse me, both the moon and the Earth have a great gravitational pull that affects the ocean's tides. Okay, so the moon pulls water up towards it, but the Earth keeps pulling it back down. That is what causes high tides and low tides. Okay, so when the moon is out, the water is pulled up. The water recedes from the shore, and when the moon is not out, the water flows back into the shores. Okay, and we don't have the water flow out into space because the Earth has a greater gravitational pull because it is much larger than the moon. Excuse me. Okay, so mm, the second another factor that affects the gravity is the distance between objects. So we see that astronauts in the space station, um, their space station is floating around the Earth in an orbit, much like the moon floats around the Earth in the orbit. The moon does not get pulled in by the Earth's gravity because it is not close enough to be pulled in. There is another factor that applies that affects with the gravitational pull, but we will talk about that a little bit later on in this lesson. Well, in this lesson. But for the most part, any object that is close enough but not too close to where the Earth's gravity will pull it in will just stay afloat. And the farther an object gets away from the center of gravity, the less effect the gravitational pull has on the object. Okay, so take a quick minute to write your response to this question. What is gravity? Okay, then I would have one or two students go ahead and answer this question for me. Okay, and then we'd move on to a secondary review. So, what do you know about the solar system? Okay, this is something we've been talking about more recently. Uh, we talked about last week. The how the planet sizes are relative to the sun, and the distance of the planets relative to the sun. Okay, so first off, draw or type two things you already know about our solar system. Sorry. Then I'd have the students go ahead and answer. Give me one of your responses, one thing that you know about our solar system. Okay. And then we review what do you know about the solar system? So we know that all objects in space were formed from floating dust. The sun is at the center of our solar system, and the seven planets revolve around the sun, including the Earth, and the planets are spread out over millions of miles away from the sun. And we also know that not only do our planets revolving around the sun, asteroids and other space rocks are also trapped in orbit and floating around the sun. Okay, so then take a quick minute to answer the question, what is a solar system? Okay, depending on how quickly the review goes, I would have them, I would play for them a video. These are quick 3-minute videos, and they have fun animations. And then I would ask them anything interesting that we saw in the videos, something we haven't talked about yet, or that we're going to talk about in this lesson that you think we may be discussing in this lesson, or something that is something of interest. Okay. And now we would go on to the main lesson, which is the gravity and the galaxy. Okay. So these are the essential questions we'll be answering. We'll be trying to answer by the end of the lesson. So, question 1, how is gravity related to objects in space? Question 2, what is a galaxy made of? And question 3, how big is a galaxy? Sorry. Okay. So, with your partner sitting next to you, go ahead and discuss what similarities and what similarities you see between these two objects. Compare the two images. This is the image of, on the left we have the planet Earth, and cut in half. And this is on the right we have our solar system, a simplified diagram of our solar system. Okay. Take another minute to compare these two. This is the orbit of the moon and our solar system. And finally, take another minute to compare the planet Earth and the Milky Way galaxy. Okay. Now take about 5 minutes, discuss with your partners, and tell me what conclusions you draw from the images. What connections can be made between these two images? Okay. And then I would have maybe 2 or 3 students give me their point of views. What did they conclude? Uh, okay. And what I'm hoping that they get out of this part is that they see that um, all objects in space have like a center of gravity, and other bodies that are orbit around it. Okay, so like the Earth has a center core, and everything is pulled towards it. Okay, and anything near or on the surface. Okay, so is the Moon. The Moon is one of those objects that's pulled around the Earth, held in orbit around the Earth, much like the planets are held in orbit around the Sun. Okay, there's a center of gravity in in all three of those, and the same with a galaxy. A galaxy has a center, and there are objects that are um, held in orbit around the center of gravity. Okay, which is at the center of a galaxy. So we're going to be talking about what a galaxy is in this lesson. Okay, so let's start off by answering the question: how is gravity related to the objects in space? Well, we know that the Earth has a center of gravity. Everything on Earth, including the layers of atmosphere, are held by Earth's center of gravity. Okay, that's at the center of the Earth. Okay, the Moon is not on Earth, but it's close enough to be held in orbit around the Sun. Around the Earth. And the gravity of Earth keeps the Moon from floating off into space. Okay, the other factor that that I had mentioned before that we're going to be talking about is the velocity. We know what velocity is. Velocity is the speed of something in a given direction. Okay, so the Moon is in motion around the Earth, and it has a speed at which it circles the Earth that prevents it from being pulled in. And the velocity is balanced with the Earth's gravitational pull, which keeps it in the orbit, keeps it from not flying off or coming into contact with the Earth. Okay, so how is gravity related to other objects in space? Gravity and velocity also keep other objects in space from floating off or crashing into others, like like an analogy, like a bag of marbles, say. Okay, they're held in their orbit because of the sun's massive gravity, but they do not get pulled in because the velocity at which they're revolving around the Earth keeps them in motion. Okay, if their velocity were to be reduced, they would be likely to be pulled in. If their velocity were to increase, they would likely fly off. Okay, so there has to be a balance between the velocity and the gravitational pull. Okay, I would have them watch this video that talks about the revolutions of the Moon around the Earth, which kind of goes over some of the points that I just went over. Okay, and I would have them to answer. Well, if this was an online, I would have them type up one thing that they learned from watching, and I would have them answer this question: what keeps the Moon in orbit around the Earth? Okay, and looking just for a simple answer, that the velocity and the gravitational pull of the Earth. Okay. And the similar answer would be the velocity for this question: what keeps the planets in orbit around the Sun is the velocity of the planets revolving around the Sun and the gravitational pull of the Sun. Okay, the key word that I would be looking for both of these is like the balance. The balance, excuse me, the balance between the velocity and the gravitational pull. Okay. What is a galaxy? So, to understand what a galaxy is, we have to first understand what a star is. Okay, we've gone over what a star is. A star is a massive ball of super hot gas. Our sun is a star, just like many other bright stars that we see in the night that light up the night. A star is so